Hey guys, welcome back to Vectors, and today we're gonna consider two problems that are actually use the same principle but different technically. Okay, so let's get started. Before you remember in the previous video, I show you the way, what if the angle between vectors is not 90 degrees so that you can arrange right angle triangle. So what do you do in this case? Here is the problem. That's typically a variance-like problem where you encounter exactly this sort of task that you need to accomplish using cos rule. Okay, let's get started. Here is John. He's driving a car for 40 kilometers in direction 250, and then for another 15 kilometers in another direction 40 degrees. So definitely they consider variance, and variance approach is the easiest one and fits up to the problem's conditions. Okay, so you need to find John's displacement from his original position. All right, so let's get started. First, as always, we set up the starting point when a John driving a car for 40 kilometers from that point in direction 250. So that's why we can set up the point that's the nose direction from that point, and we measure 250. So guys, I one more time encourage you, if this problem doesn't require you to draw a precise picture using like tools like protractors, measuring rule, so don't use that and just do it by your eye, because you need to have a sketch and all other things can be derived from that sketch. So I'm going to use the sketch as well. So right now I'm going to measure 250 degrees. So I guess it's somewhere around here. Okay. It's basically 70 degrees more than 180. So I guess if I put that line here for 40 kilometers, that would be okay. So I set up 40 kilometers here. And I set up the bearings from nose direction. As you remember, one more time and remind you, so 250 degrees. So I remind you about the bearings. It's measured from nose direction and clockwise direction to your vector. So that's the first vector for 40 kilometers. And then from the end or from the tip of that vector, using the head to tail principle, I need to drop a 15 kilometers vector in length in the direction 40 degrees. So here I'm going to set up again the nose direction. So that's the nose direction. And I'm going to set up 40 degrees. So I believe that 40 degrees somewhere here. So I drop another vector that goes somehow that way. Okay, so probably it's good. So that's the sketch. So don't worry about the angle, the actual angle. So if it's in reality be 90 degrees, and you obviously have an acute angle, so don't worry, that's the sketch, and that means that you need just to use another proportion, but don't redraw. You just need a sketch, and you can even put the words like in many problems the textbooks put. So not to scale, draw not to scale. So anyway, that's another 40 degrees angle from nose direction clockwise. So, and the vector length is 15 kilometers. So I just put 15 kilometers here. All right, so that's another vector. So we've got one vector with 40 kilometers and another 15. All right, so what we're gonna do, we need to find displacement. So I used the blue vector in order to indicate this is displacement. So displacement is always starting from in a very original position and ends up where the last vector ends, okay? Or basically, according to triangle rule of addition for vectors, we can use that chain and against, okay? So, or even head to tail rule. So no matter what you're gonna use, you should arrive to the same result. So that's the vector of displacement D. Okay, so that's what we've got. Actually, the same story. In order to find D, you need to know this is triangle. So you set up triangle. You need to know two sides, side 1, side 2. Hopefully you know that, 40 and 15 kilometers correspondingly. But you need to know the angle, okay? Ideally, if you know this angle, but it doesn't matter. So you need somehow from angles and from the properties of parallel lines and second line arrange, so find out the angle. So I bet that this angle is better defined. So let's set up theta, the angle that we're looking for. Okay, so how to work it out? Because right now we still don't know the angle value. So we cannot say, okay, let's do using cos rule. Anyway, we need first to find that. And after that, you'll decide. If it's 90 degrees, you will use right angle triangle. If it's not 90, you will use another rule, sort of general rule, which is called cos rule, to find the sides in the triangle. In this case, you can apply it to any triangle and to any angle between sides. Okay, let's see. So how to find the angle? Actually, what I'm going to use two parallel lines. And what I know that 40 degrees is in total in this angle, okay? So 40 and theta actually becomes that angle, okay? Because you see that this is the property for parallel lines, and second line that goes this way. So if you like, I can put two letters A and capital B. So AB in this case, second line that cuts some segments, right? And also two parallel lines stays for nose direction. Okay, so we've got corresponding angles. So 40 and theta together, 40 degrees and theta together correspond to that angle. How to find this angle? We know that the measure for this, because it's open angle around the point B, it's 180. So that's 180. So what about the rest part? The rest part is simply 250 minus 180. So we can say that it's also 250 minus 180 degrees. So basically what we've got 40 degrees plus theta equals to 70 degrees. Okay, so we found out that this angle is 70 degrees, and as corresponding angles, so they are actually correspond to the value of 40 plus theta. So we can set up this equation from where theta angle is 30 degrees. Oh, and we first arrived to the problem where is the angle between vectors is not 90 degrees. So we cannot use right angle triangle and Pythagoras theorem. So we would rather use cos rule in order to find, the side. The side in this case D, so that opposed to the angle theta. Okay, so generally, one more time, how the rule, I'll remind you. In the previous video, I actually barely touched that, but on general explanation. So here, I'm gonna give you the proper explanation how it works. So you've got, let's say, two sides A and B, and the angle between them. So the angle is theta. You need to figure out the value for C. Let's say this is 1, this is 2, and theta, let's say 30 degrees. I'll just show you how it works generally, and then we apply it to our case. Okay, so we know, according to the rule, so just watch out, it's sort of Pythagoras. C squared is actually A squared plus B squared. However, we need to adjust this formula in order it will be workable. And we adjust by minus 2AB by cosine of the angle between them, cosine theta. So that's the general rule, and this is an adjustment. So it's pretty easy to memorize, okay? Pythagoras and subtract 2ab cos theta. So by the way, you can apply to any basically sides in order to find that side if you know two other sides and the angle between them. Okay, so you also can memorize using another approach. So just remember the formula a minus b squared. It actually works like a squared plus b squared and then minus 2ab. So this form is already here, except for you need to add cos theta between the sides. So cos theta is what actually missed in this formula. So it looks like the same, so you can have two ways of how to memorize that. I think if you write several times, you can basically get this formula in mind. So, okay, so that's what we're going to find. And in this case, I'll just show you that c squared is simply 1 squared plus b 2 squared minus 2 times a times b is going to be 4, right? 2 times 2 is 4. And cos theta. So cos theta, that's what we want to calculate. So I know the standard value cos theta of 30 degrees is actually square root 3 over 2. But you can use calculator in order to get decimal value if you like. So let's see that. Let's calculate. So we've got cos of 30 is going to be this value is going to be 0.866, so 87 roughly. Okay, and if we calculate next, we're going to take the square root of. So let's do it right now. Square root of 1 squared and 2 squared is going to be 5. So 5 minus 4 times cos 30. Okay. So c in this case is going to be 1.24 to 2 decimal place. Okay. So that how it works on the example. So if you got it, how it works, now we just simply apply this rule for our problem. And let's set up the same formula. So c squared equals to a squared plus b squared minus 2ab cos theta. In this case, cos theta is also 30. Hopefully, we don't need to recalculate. The value we've got already is here. So now just simply let's set up d as square. Okay, so d squared first. It's 40 squared, that's one side. 15, that's another side. So we've got plus 15 squared. Then minus 2 times 40 times 15 and times cos theta in the end. Okay, so in this case theta I changed to 30 degrees so that it will have some value that we actually calculated, and the displacement is actually, let's calculate now. So we've got square root of, and now 40 squared, I just used the one line calculation, so 15 squared and minus 2 times 15 is 30, so 30 times 40 and times cos 30, okay, cos 30 degrees. Okay, so that I've got this way, I've got displacement to be 28.03 to 2 decimal places. So that's the value I've got it. Okay, guys, it looks fair, right? It moves slightly back, so displacement is going to be shorter than 40, definitely 40 kilometers. So the value is given in kilometers, and that's the clue and the final answer for that. Okay. So guys, that's how it works. Actually, knowing all three sides and knowing one angle, we can figure out all other angles. And if you're asked to find, let's say, at which bearings, at what bearings, right, displacement vector is set up. So actually, you need to calculate, let's see, which angle you need to calculate. So you've got already 250, so the bearings is measured in clockwise direction. So you need to get this extra angle, let's say x degrees. And for example, how to do it practically, I'll show you. So that's the complete bearing. So if you want to calculate the bearings of vector D, of vector displacement, is simply x degrees plus 250 measured from nose direction. Okay, so you need to have angle x in this triangle. So how to figure out angle x? You know theta is 30 degrees, you know D, you can use sine rule, okay? So how the sine rule actually works. So I show you on some random triangle. So that's about how sine rule works. So you have the side A, you have the angle alpha, let's say. You have the side B, you have to know the angle, let's say, beta in degrees. So the sine rule for that triangle, sine rule, it connects sides with the angle, with actually sines of the angle, so it works. You're taking the side to the sine of the opposite angle. So you're taking this ratio A to the sine of the opposite angle, in this case it's alpha, and this ratio stays the same, so it's not changing no matter which side you take, and for example in this case B, and you relate it to the sine of the opposite angle B, okay? And actually if you input the third angle, let's say gamma in degrees, so the side C is also equal to C over sine gamma, okay? So that's the sine rule for random scalene triangle. It works like a ratio, so this ratio stays the same, okay? So what we can do, we can apply this rule to our case, okay? So in our case, one more time, so what we're going to define? We're going to define this small angle x in degrees. So this small angle in degrees relates to the side of 15, right? So we can set up the same proportion as here, and I'll show you right there. So we're taking 15, that's km, the length, and we divide it by sine of the angle x, okay? And that will be equal to, so what we know angle theta. So that's why we can figure out D, displacement, which actually 28.3 kilometers over the sine of the angle theta, so sine of 30 degrees, which is actually 1 over 2. You can check by using calculator. Okay, so we've got that from where we can determine sine x, okay? Just remember it's fractional equation. However, sine is a specific function of x, but generally first you need to find the sine, so it's fractional equation. So that's sort of the value t. If you like, you can rechange t equals sine x, from where you have an equation 15 over t equals 28.03 to sine 30. So you can calculate sine 30, but I'm sure it's 0.5. Okay. So now you use the fractional equation, and first you taking and trying to define value for t. It's here. So crisscross. So just remember how it can be resolved, crisscross multiplication. But I simply swap t and 28 over 3. So I've got 15 times 0.5, and over that 28 of 3 equals to t. But instead of t, I will use sine. So I go back and say, okay, this is sine x. You see how we change input new variable was really helpful here. Okay, so that's sine x, from where actually you can figure out that x in degrees is sine minus 1 of what you've got here as a fraction. So let's try to do it. So 15 times 0.5 and over 28.03. Okay, so we've got the value 26, and okay, that's an 8. But you can do it one-way calculation, so using sine minus 1 of that value, it gives you around 15.52 degrees. So 15.52 degrees. So that's why the total bearing, so we've got the angle x, it's 15.52. So the bearings of D is simply, one more time, go back to the picture. So the bearings D is that vector. So the bearings is from there, from north direction, all the way through 250, and x as the extra angle in order to arrive to D vector, the vector D. So we've got x plus 250. So in total, we've got 250 and 15.52. That's degrees. So that's the bearing, okay? That's the final bearing, which is 265.52 degrees, okay? That's the final bearing. So actually, even if it's not right angle triangle, you can use sine rule, you can find the length of the displacement, and you can also find the final bearings of this vector relating to north direction. Okay, so guys, we've got one more problem here. So, and I'll show you in the next video. Right now you can print screen and try to solve by your own. Thank you guys. Don't forget to subscribe. I really appreciate new subscribers coming, and all my old friends that are here that watching that. Hope you enjoy. Hope that it's really helpful for you guys, at least at specific topics. I understand that you cannot watch like everything, but for some topic where you need to clarify the concept, where you need to clarify how to solve the problems, in which way. So I'm trying to do everything for you guys. Need help and have this help. You're Daniel Dallas. See you later.